We show the hyperlink structure of a small website using the H3 layout and the H3Viewer drawing algorithms. Both layout and navigation occur in 3D hyperbolic space, which provides a view of a large neighborhood around an easily changeable point of interest. Nodes appear to shrink when they move from the center of the sphere towards the periphery. The entire structure always stays within the confines of the enclosing sphere. When the user clicks on a node, it undergoes an animated transition to the center of the sphere, which includes a rotational component so that its ancestors are on the left and its descendants are on the right. This canonical orientation helps orient the user locally. The user can also rotate the entire structure around the center of the sphere, which helps disambiguate its three-dimensional form. Instead of drawing every link in the graph, we are only drawing the links of a spanning tree which was used as the backbone of the layout algorithm. When we show all the links of the full graph, the view becomes very cluttered. The interactive interface allows the user to select one or many nodes and display all incoming or outgoing links for just those nodes. The non-tree links are drawn with narrower lines than the main spanning tree links. All links are drawn with a subtle color coding to indicate directionality. The reddish end is outgoing and the bluish end is incoming. This effect is understated for individual links, since when the spanning tree alone is drawn, the directionality coding is redundant. However, if many links are drawn, the aggregation of many links can show sources and sinks. In this dataset, many nodes have no or only a few non-tree links. But the table of contents document for the site has a large number of links, both incoming and outgoing. The choice of spanning tree heavily affects the user's mental model of the site. Many graphs, which are relatively heavily interconnected, are in fact appropriate for this technique when a small amount of domain-specific information is used to guide the spanning tree construction. This spanning tree was constructed by the simple method of using the best match with the directory structure encoded into the document URL to choose which of the incoming hyperlinks would be the best parent for a given node. We now switch to a function call graph of 800 nodes and 4,000 links, which is roughly the same size as the small website we were previously inspecting. Again, drawing all the links yields a messy picture, but drilling down to inspect a small subset of the nodes can yield fruitful information about connectivity. In this case, the spanning tree criteria were based on CPU usage as determined by a combination of compiler and runtime analysis. If no domain-specific criteria are forthcoming, a fallback breadth-first search can be used to create a spanning tree. If there is in fact no inherent hierarchical structure in the graph, or the spanning tree computation does not match the user's mental picture, then this layout technique might be actively misleading. We now move on to some bigger and sparser graphs. In this Unix file system, we have 28,000 nodes and 31,000 edges. The branching factor of files in a directory like dev or user_lib is much larger than in the earlier websites. Our H3 layout algorithm was inspired by the cone tree system from Xerox PARC, but strives to balance information density against visual clutter. We place child nodes on the surface of a hemisphere at the mouth of the cone, instead of on a line around the cone circumference. Full details appear in a paper presented at the 1997 Symposium on Information Visualization. One consequence of our layout technique is that the child node with the most number of descendants falls at the pole of the hemisphere. This knowledge can help a user exploring a large unfamiliar graph find complex and thus potentially interesting places. We can load an even larger Unix file system, where the graph shows several NFS-mounted disks of user directories, using a total of 10 gigabytes of disk space. There are over 112,000 nodes and 113,000 links in this dataset. Note that although this graph is very large, we are viewing it at a guaranteed frame rate. When the user is dragging the mouse or the structure is in the middle of an animated transition, the graph is drawn at 20 frames a second. Our adaptive drawing algorithm uses graph-theoretic information to add nodes to a pool of potentially drawable items, and sorts that queue by projected screen area to determine the next best choice. Nodes are drawn until the allotted time has expired, and then controllers return to the user. During idle times, the periphery is filled in. The H3Viewer algorithm was designed to allow interactive navigation of both very large graphs on powerful computers and medium-sized graphs on low-end machines. A graph viewer is most helpful to a user when it is integrated with other tools. We now show how the H3Viewer module has been integrated into the Site Manager system from Silicon Graphics, which is aimed at webmasters and content creators. The graph shown is part of the Stanford Graphics Group website, with 14,000 nodes and 30,000 edges. The 3D hyperbolic graph view shows the hyperlink structure of the site, while the 2D browser view shows the directory tree structure in traditional outline format. Selection in one view causes highlighting and transitions in both. The graph structure can thus be used as an index for selecting items. The ability to quickly select a subtree can be useful even for users who already understand the structure of their graph. The graph view does well at supporting browsing and showing the relationship between parts and the whole. This layout is not well suited for searching, which is handled by a third window in the main application, which is also linked to the directory and graph views. We finally switched to another small website. The default color coding of nodes in Site Manager is according to MIME type. HTML documents are cyan, images are purple, vermel is blue, and so on. An alternate static coding based on traffic logs stored by the web server is also available. Traffic logs can also be used in a dynamic animation, where hits between documents are replayed as bright link flashes between the nodes. The camera can follow the link flashes, or the user can have manual control of the graph while the animation plays on. The July-August issue of IEEE CGNA will contain an article with further discussion of the H3 and H3Viewer system.